All right. We have connectivity across our network. Everything is working, but it's static routes. If our network grows, we're going to have a huge headache on our hands. So how can we fix this issue? Dynamic routing. Now, we have a choice of different routing protocols as we discussed at the beginning or earlier in the introduction to the course. We have 3 routing protocols: RIP, EIGRP, and OSPF. The first routing protocol that we're going to configure is RIP version 2. RIP version 2 is considered a distance vector routing protocol. It works just fine for small networks. You can only go up to 15 routers. Beyond 15 routers, RIP will not work. Okay? And there's a command, as we do it, I will emphasize it 20 million times because you cannot forget it. It's easier on you because instead of telling the router, hey, these networks exist beyond this point, you're telling the router, hey, these are the routers that I'm connected to, and you're going to snitch yourself out to your neighbor. And that's what it is. You're snitching yourself out. This is called routing by rumor. Let's go ahead and jump right into that, and we'll explain as we go. Okay, so let's move this a little bit this way just so I can work a little bit easier. And we'll keep there. Oh, okay, the window's fine. Perfect. And we can see the IPs we're working with. Okay, config T. Now, when you're doing a routing protocol, you start the command with router, and then the routing protocol you want to use, RIP, enter. And then what we're going to do is say version 2. And I do this right away because I don't want anybody to forget to do that the router is going to be using version 2. And now we do something called network statements. What networks are you actually plugged into? Now I'm going to do something here. I'm going to prove a point to you. I'm going to go ahead and pull or put the exact network that I am connected to, which is 10.1.1.4. And then the next network is 192.168.1.0. Next. And this is a command that I'm going to drill so much into your head that you'll be dreaming about it. No auto -summary. You cannot forget that. And after I copy this, I'm going to tell you why. I want you to pay attention to this number right here. Pay attention to that number, and you're going to see what RIP does with it. I'm going to exit. I'm going to exit. And then I'm going to do a copy run start. Enter. Enter. Show IP route. Not show IP route, forgive me. Show IP in brief. All right. And this is a good command to look at your routing table, but what I really wanted to show you was the show start. And we're going to scroll all the way down. Look what happened here. I didn't put that in. I put in the exact network, 10.1.1.4. What did RIP do? RIP actually, or any distance vector routing protocol, will summarize the network to the class full boundary. And that could propose a problem if you do not type this command right here. Because if you don't type that command, and let's say your network is all 10 based, class A, it won't know where to send the packets. That's why the scientists, the powers that be, said, hey, we're going to come up with no auto summary. That's why version 2. And what that's going to do, it's going to send the true subnet mask out on the updates. So for distance vector routing protocols, you will configure no auto summary. Okay? I can't drill that enough in your head. So let's go ahead and go to the next network. Let's go to the next router, I should say, and do the same exact thing. Let's go to router 2. Let's move our little table over so we have room to work with. And I'm going to purposely do the same thing again so you can see. Config T, router version 2. And now network 192, no, not 192, 10.1.1.4, enter. Network 10.1.1.8, enter. And then network is the LAN 192.168.2.0, enter. And what command can we not forget? The no auto summary command. Now, one friend that you have in here in your configuration is the tab key. If you type enough of the command and you hit tab, boom, it finishes it for you. That's great. Okay, hit enter. And I'm going to exit, and then I'm going to copy, run, start. Enter, enter, right? Now let's take a look at the show start. Look what RIP did. It took out both of those networks that I had in there and they summarized it to the class A. So really, when you're advertising any distance vector routing protocol, you advertise the class full boundary. You just can't forget this command right here. Cannot forget. All right, let's do the last router. And again, let's move it over so I can have more space to work with. Config T, router RIP, version 2. Network, but this time I'm going to be smart. 10.0.0.0. If it's going to summarize it anyway, I might as well just put that. And then network 192.168.3.0. Enter, and our famous command here, no auto tab. I tabbed, that's why that happened. You know that I have to exit, and do copy run start, but this iOS supports you doing do WR. So why go all the way out when you can actually do it right here, and it's a lot quicker. Hit enter. So now let's take a look at our start, and I can do it from right here by doing the do. Do, show, start, and hit enter. All right, let's take a look at our RIP. Well, look, there's our RIP. It did what it always does, right? So let's do a Control C. And now I want to look at the routing table. Do, show, IP, route. Now, before I hit enter, what should I see? I should see a bunch of R's and C's. So let's see if that's the case. And it is. Here we're looking at RIP. I'm learning about the 10.1.1.4 that has an administrative distance of 120 and it's one hop away. I'm learning it via the 10.1.1.9 on my serial 001. That's how you read that. So RIP indeed is working. Look, all the way from the 1.0 network, which is 2 hops away. So I am routing at this point. So let's see if that's true. Let's go to this server. Let's go to the command prompt and let's ping. Ping 192.168, and this is the true test, 168.1.1. There's your PC. I'm going to do a Control C. I'm going to up arrow, do the 2.1, enter. Got connectivity there, and then obviously I can ping myself, 3.1. So we have full connectivity across the network, but what exactly are we doing? Let's open up this last router. Think about what's happening. We're using a default route just in case there's a network that doesn't exist in this routing table. It will use that gateway of last resort to get to that particular network, okay? We have static routes. Let me do a show start. I never took them out. I'll do a do show start. And the reason that comes out is because I mistyped something, and the way you get rid of that, I'm so glad that happened, is a keyboard combination. Control Shift 6 gets rid of that, and do a do show start. And here we see both. We have our RIP that's running, and we also have our static routes. But why did RIP make it to the routing table and not the static routes? RIP took over. Why was that? Because of this number right here. The administrative distance of the static routes now is 150. What's the administrative distance of RIP? 120. So there you go. You have actually 3 methods of routing. We're using default routes, dynamic routes through RIP version 2, and if RIP version 2 goes haywire, we can go ahead and use static routes as backups. So 3 ways that we can route across this network. All right, we have our infrastructure set up. We chose to use routing protocol RIP, but we do have our static routes. And what I'm going to do is I'm going to open up router 1, and let's move it over here. We'll set up our little window so we can take a look at what we have. Let's get rid of this gibberish. Show, start. And what we can see is we have our interfaces all complete. Here's our RIP. As you can see, it has the classful boundaries for each class of address, but we also have the static routes. And that's one thing we need to talk about. We need to talk about, one, the process of routing, and two, the dynamic routing process or the static routes. Which one should we use? So let's talk about that. While we can keep this up here, it's not a big deal. What happens in the routing process is the following. When PC1 wants to send, let's say, PC2 a ping, we all know that's an ICMP request and reply. When it's the very first time, what happens is PC1 sends an ARP request to the gateway of router 1, which is the F00. Router 1 then replies, hey, here you go, this is my MAC address. Once PC1 receives that, it completes the frame and then sends it to the router. When the router 1 that is, I'm going to minimize this just to get it out of the way. When router 1 receives that particular information, that frame, it actually discards any layer 2 information because ARP is local to your segment. So it takes a look at the layer 3 information, looks at its routing table and says, hey, where do I need to send this destination? It sees that it needs to send it out the S000 based on the routing table. Once it gets to the other router, that router does the same thing. It takes a look at its routing table based on the layer 3 information, sees that it has to go out the F00. Now we're talking about Ethernet, and ARP only happens on Ethernet. So it must know the MAC address of PC2. Sends the ARP request down to PC2. PC2 says, hey, that's me, out of all the 200 or 2,000 IP addresses or computers that are there, and says, okay, here's my MAC address, default gateway, router. And when it completes that frame, then it can send down the frame to PC2 where it completes the first part of the ICMP request, and then the process repeats itself on the way back. So you can see it's a large process. We take for granted when we ping that things should happen right away. But look at everything that needs to happen to get from point A to point B in a simple ping. It's one way to get the ARPs, and then the other way, the same process. So it is a process. So not only do we need to understand that that is going on, but we chose RIP. Why did we choose RIP? Well, it's a dynamic routing protocol, makes the life of the administrator a lot easier. All you need to do is tell your neighbor router, hey, this is who I'm connected to. This is called routing by rumor. So we're only connected to these two particular networks. If you were to choose static, which we did earlier, it's manually. You got to actually create the routing table one by one by one by one, telling the router, hey, these networks exist beyond a certain point, which is very cumbersome for the administrator in a very large network. So definitely dynamic routing is the way to go. But we chose RIP. Why not EIGRP? These are Cisco routers. They're proprietary to Cisco. We could have used EIGRP, but it's not a large enough network. Not a large enough network to use EIGRP. EIGRP, 100 to 250 routers. That's its limit right there. So medium-sized to large networks. Why not OSPF? Well, OSPF is for very large enterprise networks. Thousands of routers, hundreds and thousands of routers. But OSPF, good thing, is multi-vendor. Bad thing, if you want to consider it a bad thing, that is very processor intensive. That would be the only thing. We actually chose to use RIP version 2, and for this network, that works perfectly. So now that we have RIP running on our network, now it's time to make sure that all